Hi, and welcome to this presentation about how a digitalized lab should look and feel like. This presentation is thought to be an inspiration for you, and I will tell you a few insights on what we believe is important to consider when you digitalize your lab. It is what we call a digital lab in a nutshell that we're going to show here. And it is all enabled by the use of standards such as CELA, NEML, and BPMN. And we will talk about these standards in a minute. But it's also around a few other components that make up successful digitalization. But first of all, I'd like to give you a very brief introduction who I am and where I'm from. My name's Daniel, and I'm actually a chemist by education, but have been working in the informatics space throughout my career and have been dealing with lab automation and lab automation solutions and software throughout my career. Now at Vega, we're specialized to building the bridge between business and IT. And basically it's everywhere in labs and lab environments, in life science, pharma, where you do need informatic solutions to manage your data or processes in labs. Vega itself is organized in 4 pillars of excellence. 2 of them are domain specific, the lab and research informatics and the clinical development informatics. As the names imply, the lab and research informatics actually starts at the very early research of a new product. And it actually also goes even into the QC and regulated spaces where it is about labs and processes and data. And of course, as you know, especially in the pharma product development life cycle, after the latest development, you actually have to do a clinical development, and clinical development informatics also does need a lot of informatics expertise to actually implement such informatics solutions to help working with your processes. And then depending on the area where you're in, whether or not the lab is regulated or not, the computerized system validation team and quality assurance team comes into the game as well when it's about validating a system or running a system in a validated environment. But as well, there is technical bits and pieces. So this is where the informatics solutions team comes into the game. Just imagine you do have a LIMS project. So people from actually the lab and research team could help you do the as is and to be process analysis, the requirements engineering, and help you doing an RFP to find the perfect vendor for your needs. But maybe, and probably very often, your LIMS is in a regulated environment. So we will also have people from the computer system validation in the team, very much at the beginning of the project, when you have to actually deal with setting up validation strategy, the validation plan, whatever type of governance you'd like to apply in the project. But then in the course of the implementation of the project, you probably also do need integrations with other systems, instruments, ERP systems, etc. And this is where the informatics solutions team comes into the game. And interfacing to other systems is definitely one very important aspect that we're going to talk about now when we're talking about lab digitalization. Now, last slide about Vega. Why actually are customers working with Vega? Now, most of the time, I think one of the predominant reasons is our employees all have a dual qualification in some sort. They basically come from a life science degree or from an informatics degree and actually have educated themselves, so to say, into the other area and combine the dual qualifications on the one hat. So all of us are able to build the bridge between business and IT in your informatics project. We do understand the business as well as the informatics requirements. And then We have been in business for quite a long time. We are actually this year in our 28th year and have been successful over all these years and independent as well. We are also vendor neutral. We don't have any commercial relationship with any of the lab informatics providers, but we do have partnerships and strategic partnerships with these vendors. So we always know the latest and greatest products and the features and have our people trained. But we also very much engage in innovative initiatives, and we will talk about standards later. We also looked into how can blockchain technology be used to maybe secure audit trails in distributed lab systems, or very important, how can you actually implement the LIMS in an agile way? How do you apply agility in non-agile environments? Now, so much about Vega. Now I'd like to actually dive into today's topic by introducing into how a digitalized lab should look and feel like. Again, as I said, this is thought to be a food for thought and inspiration. And before we go into the key foundation of what we believe is important for successful digitalization, I'd like to start just with a few different viewpoints or viewing angles about digital transformation in a lab. Depending on who you are, you probably think about different things when I say digital transformation in a lab. Maybe you first think about automation. And probably if you think about automation, you also think about robotics. You might also thinking about automating data flow or sample flow or processing, right? Maybe if you talk to somebody else, they think about, okay, digitalization for me means everything's accessible. The data is at your fingertips. There is tools for collaboration and online access to anything. And of course, that probably very quickly leads to, okay, if you want to do that, everything needs to be connected. And hopefully the things are plug and play while integrated in a regulated environment. And maybe not only there, you like to have great data integrity. Things have to be reliable. Very often digitalization projects also start with, oh, let's apply some machine learning and artificial intelligence mechanisms to automate my lab. Well, this is all valid and all true. What we want to say here today is that successful digitalization actually bases on 3 different pillars. So the first one, of course, you need to have a proper technical architecture, which is based around an integration layer. I'll talk about that in a minute. But this is not everything. So digitalization is not a technical issue at all, and definitely not only a technical issue. We also believe that you should use standards, make proper use of standards, such as the standard in lab automation, CELA for connectivity, the analytical instrument markup language for your data, and the business process model and notation for your workflows. But last but not least, I think it is very, very important that you put the human beings, that you put the lab technicians, that you put the people working in the lab into the center. The user experience and usability of digital lab solution is of ultimate importance. And if you forget about that, you will fail in your digitalization project. So digitalization, even though it sounds very technical, is very much a human issue. First, I wanted to just give a quick insight on architecture. Now, you don't need to look at these quite complex slides in detail. Focus on the center, on the integration layer. We believe that it is a very good approach to focus your integration architecture around an integration layer, which has 3 main purposes. One is decoupling of the systems, so that systems like a LIMS system and maybe a chromatography data system can have different life cycles. I think this is very important, but also quite common practice and good practice. But also, this integration layer should deal with a specific level of workflow orchestration. Think about data in your limbs. You probably do have sample specifications and results in your limbs, but it probably don't track the workflow, how you actually come from a sample via a sample preparation, maybe via measurement and some analytics and some evaluation of the data to the actual result. And this level of workflow orchestration you can actually do in your integration layer. You can actually put these things that you would not cover in your enterprise application layer systems, but you still need to operate your zoo of instruments down here into an integration layer. Last but not least, data standardization is very important and is one of the key features of the integration layer. You know that there is a big zoo of data producing systems in labs. And you all know that there is also a big heterogeneous zoo of proprietary format software solutions whatsoever in labs. And this will probably also remain for a while. So all the software tools, all the data producers that don't produce any data in standardized format, latest on the integration layer, standardize your data, at least meta information of the data, at least some of the data that is useful in the context of enterprise application layers, or maybe subsequently in a data analysis layer later on in the downstream process. Now, the integration layer is actually a key for successful digitalization. As I said, to repeat, it's about workflow orchestration, metadata capturing, basically apply the data integrity mechanisms, etc., etc. But to actually successfully do that, now you see that connectivity and data standards are very, very important to actually arrive there. Why is it so difficult in our industry to get vendors actually complying to standards? Look into other industries. Look into in the automotive industry. A vendor that doesn't comply to a standard is just not able to sell a product. In our industry, it's still possible, but this will change in the future. So actually, standards that allow different systems, and you just see this is a heterogeneous zoo of systems, hardware and software components that need to be able to actually find each other, describe their capabilities so they can actually command or orchestrate each other. I think it's pretty obvious that you need a common language to actually connect systems with each other as a foundation for digitalization. And maybe if you speak in mathematical terms, I think standards are definitely a necessary condition, but you will see that in a minute they are far from a sufficient condition for lab digitalization. Now, in our projects, we have been proving in the past that a combination of a connectivity standard like SILA, standard in lab automation, NEML, the analytical instrument markup language for data, and the BPMN for business process modeling is actually an excellent combination that you can use to successfully digitalize your lab. Now I had a third point on my initial slide where it was about the successful foundation for digitalization. This was the focus on usability. Usability is a key for digitalization. User experience is very important. Just think about maybe your first thought might be, let's bring tablets or other fancy stuff like Google Glass, etc. into the lab. But is that really usable? Does a tablet work with gloves? Does it actually withstand the nasty chemicals? Would Google Glass be accepted? Does it actually work? Does the battery last for a whole day? Right? So what we say here, you should bring the user interface as close as possible to the user. You should do at least invasive automation of the lab. And users usually don't want to be controlled by a workflow engine, but maybe they want to be notified if they don't do the right things, if they don't follow the process, if they enter wrong data or in a wrong sequence. I think this is important. The user should be guided. The SOP in a regulated environment, for instance, should be strictly executed. But maybe users don't want to be put into, okay, please do this, please do that now. But they actually know exactly what to do, but the system should notify them if they miss a step or if they do the step wrong. So to actually show that in a more tangible way, we created what we call a digital lab in a nutshell. What you see here on the screen is fully functional analytical instruments. Of course, they're not of analytical quality, but for a demo purposes, all of these instruments are fully supporting the CELA and animal standard. You see a spectrophotometer, you see a balance, an environmental monitor, a scanner. We did other devices like a printer, etc., that all support data and connectivity standards like NML and CELA, and they're all orchestrated by a workflow software around the BPMN, business process model and notation. We will show that to you in a video now, and after the video, we'll discuss a few details about it. Enjoy.
Let's discover together how it feels like to work in a digitalized lab. In the production facility, samples are created and need to be analyzed by the lab. The samples are logged into the laboratory information management system and a test order is created. The quality control lab receives samples for testing. The lab technician uses an active scanner to scan the sample. The sample ID is sent to the LIMS and a list of tests that must be performed on the sample is returned. The lab technician selects the sample preparation. A label is automatically printed. The target weight and its tolerance are retrieved from the LIMS and displayed on the balance. After pressing the tare button, the lab technician weighs in the sample. The visual indicator turns green as soon as the sample weight is within the tolerance limits. The weight is transferred to the LIMS and the result is displayed on the balance. The weighing is now completed, the scanner becomes active again and is ready for the next sample. This was a quick overview on how it feels to work in a digitalized lab.
With this video, you have seen how successful lab digitalization can feel like. Now, you might be wondering, what if my instruments and my systems in my lab do not support the standards, do not support CELA or animal? Now, this is where Converter Box is coming to the game. Multitude of open source, freely available, and also commercial Converter Boxes exist. Please watch this video to see how this works.
Devices that do not have CELA integrated can easily be converted into a CELA server by connecting a CELA converter box. The lab technician connects the CELA converter box to the label printer. A simple plug-and-play principle is used to make any device CELA compatible. The printer is now a CELA server and can be discovered by CELA clients. The CELA server for the label printer has a feature called Label Printer Controller. We use the UniteFlow CELA client to execute the print label sample command. First, the parameters have to be entered. Then the label is printed by clicking the Execute button. The parameters entered by the user appear on the printed label. If you're interested in Sealer Converter Box, please visit our website.
In this video, I've seen how helpful a converter box can be to actually connect your legacy devices using the Sealer and Animal standard. Now, why are standards like Sealer and Animal superior to other initiatives? Now, this is very easy. Sealer and Animal both don't try to standardize everything. Sealer and Animal, they actually standardize how you describe your data or your connectivity in a standardized format. And this is a very, very big plus to anything else out there, because you can be sure that vendors and systems will be coming out with new features and new specific details they support. And usually they don't want to wait for standards to be there. Watch this video to see how universal discovery works.
In this video, we're going to demonstrate to you how the Sealer client and server interaction works. The lab technician switches the device on. This device is an environment sensor that records the temperature, pressure, and humidity of the environment. As soon as the device is switched on, the Sealer server sends out broadcast messages that can be discovered by Sealer clients. To search our device, we use the Sealer server discovery in Unite Flow by pressing the Scan Network button. The environment sensor is found. A green dot on the upper right hand side indicates that the device is online and ready for operation. The Sealer client has discovered the features of the Sealer server. We use the interaction service feature to display a message on the environment sensor. For this purpose, we type a text for the message parameter in the display command. We are now ready to execute the command. Instantly, the message shows up on the device screen. In the humidity, temperature, and pressure feature, we select the refresh button for the property temperature. This queries the current temperature from our Sealer server. If you want more information about Sealer client and browser, please visit our website.
You have now witnessed the power, data, and connectivity standards like Sealer and Animal. Now let's have a glimpse under the hood. Let's have a glimpse into what happens when you actually combine the power of a connectivity standard like Sealer, a data standard like NML, with a business process model notation to actually orchestrate your workflows in a lab in a very efficient and easy to use and flexible way. Watch this next video.
Let's discover how a business process model and notation, or BPMN workflow, can assist the lab technician to measure a sample in the UV-Vis spectrophotometer. The lab technician places the sample to be measured in the UV-Vis spectrophotometer. Unite Flow is based on the Camunda open source BPMN implementation that has been extended by Sealer Task. For demonstration purposes, a workflow is created in Unite Flow. Every BPMN workflow has a start and an endpoint. Sealer tasks can easily be dragged and dropped into the workflow and configured afterwards. We use the command measure sample from the UV-Vis controller feature to configure the Sealer task. To provide visual feedback to the technician, we configure two more tasks which will control the LED lights on the device. This task uses the rainbow animation command in the light indicator service feature. We are now ready to start the workflow and measure the sample. The measurement is visually supported by the LED animation.
A digitalized lab could look and feel like in the last couple of minutes. Now, let me summarize a few of the key essential items, and then also provide you a few internet links for your reference. Now, first of all, you have seen in the videos that Sila and Animal basically enables you to implement a digital twin into your lab. So you have a direct in-sync combination of your physical reality and the digital world. Now, we also showed you how important it is to actually get close to the user, to implement an excellent usability and user experience. We showed you how haptic and visual feedbacks can actually be integrated in your workflows to make working in our lab fun with digitalized solutions. The visual feedback you've also seen is very, very important. So a lab technicians immediately know whether a result is good, whether an error has happened, whether a target is met, etc. And of course, monitoring. It's very nice. Now, on this slide, you see links to the standardization organizations, CELA, BPMN, and NEML. Feel free to go there and get some more insight. You might also want to contact us. Feel free to reach out to me. Feel free to reach out to Vega to get further information. And I'd like to thank you very much for your attention, and I hope to talk to you soon. Thank you very much.